Certainly, the greater Yellowstone ecosystem as we know it today would not exist if it wasn't for a really important act, the Endangered Species Act. And that's really where I want to pick up today and start off with today. So as we look at the Endangered Species Act, it defines wildlife species being that they are of aesthetic, ecological, educational, historical, recreational, and scientific value to the nation and its people. And I think that's an important definition and an important part of the Act, actually, to define the value of wildlife. The Endangered Species Act was enacted in 1973. The agency that is primarily responsible for protecting endangered species is the U.S. Fish and Wildlife Service. And as part of its duties, it will identify species to be listed as endangered, which get the greatest protections, and then also species that are considered threatened species, which have lesser protections. And effectively, the definition of an endangered species is one that is in danger of becoming extinct in all or part of its range, and I'm going to come back to that definition in a minute. And threatened species are those that are in danger of becoming endangered in all or part of their range. And then there are other protections as well, but those are the major types of identification and protection. So the Endangered Species Act, then, a couple of important aspects of it is that it protects, quote unquote, critical habitat, and that's an important phrase in the Act. And when we think about that, if we take a look at the example of the whooping crane, for example, it's one thing to protect where they spend their winter range, where they spend their winter, and then also where they nest in the summer. And so we can and have protected those, and that is critical habitat for something like the whooping crane. But you also have to protect their migratory pathways as part of that as well. So this is part of that critical habitat, not just where they spend the winter, not where they spend the summer, but how are they going to get to those places and back. So that would mean as they migrate, there are places where they have to stop and rest and feed and so on. And so those would be areas that have to be protected as well. So sometimes this involves, establishing treaties with other countries, as in the case with Canada in this case, but also protecting all of that habitat, which is critical to survival of the species. And this is something that I'll be getting back to then. If we want to protect species, we have to protect habitat. They have to have a place to live. Another important aspect of the Act is that it protects species in all or part of its range. And this is important because it helps protect the genetic diversity of species. So we're not just going to protect a particular species, but subspecies and varieties of species as well. This helps keep genetic diversity in a species. And this is something we talked a little bit about earlier in the course, but one of the problems with a small population is that it leads to inbreeding, and then also genetic drift can set in. That leads to a loss of genetic variability, loss of fitness. That eventually leads to lower reproduction, higher mortality, and of course the population will get smaller as a result of that. So by protecting subpopulations, it allows for possible transfer of individuals from one group to another to boost genetic diversity periodically. And a couple of the populations that are really quite small in the Yellowstone ecosystem would be the sage-grouse would be one, bluegrouse would be another. These are isolated small populations and are at great risk for loss of genetic diversity. There have been a lot of attempts to modify the Endangered Species Act over the year. One of the ideas is to identify, rather than protect all of these species that we currently are protecting, one idea is to protect so-called keystone species. And the idea is in an archway, you have the keystone. If you remove the keystone, the archway will collapse. And anyway, this is an idea that hasn't really stood up to scientific scrutiny, in my opinion. Again, the idea is that perhaps there's just one or perhaps two species that are crucial to the entire ecosystem. And if you protect those, then you protect the entire food web. And again, that just hasn't held up in scientific scrutiny. There's just not one or two that actually establish the whole ecosystem. The entire food web is important. And as we've learned, as you introduce species, alien species that are not endemic to the area, or if you remove species which are endemic or natural to the area, this leads to a variety of changes. But that doesn't involve just particular species. It can be a number of species that are affected here. So bottom line is the Endangered Species Act works, and so it doesn't really need to be messed with, in my opinion. There's also a big political push to delist, and we've talked about this a little bit already. the grizzly bear has been delisted, the wolf has been delisted, at least in Idaho and Montana. And that push will continue. And this is more or less politically driven, and the political push is that, and the explanation is, or the justification is, that there's a group that says that the Endangered Species Act doesn't work, that you have species that have been listed since the beginning of the Endangered Species Act, they're still listed, therefore the list doesn't work. And the problem is that's just an absurd argument, quite frankly, because those are all populations of species that were crashing dramatically. The fact that they still exist at all is a testament to the success of the Act. That's not a failure of the Act, that's the success of the Act. However, this argument does have some political traction, and even though ideally our agency should be working independently of the politics, this is where political appointments come in. With each new administration, they will be making political appointments, they will have priorities, and if you're an administrator in those different agencies, if you want to keep your job, you basically do what your superiors want you to do. So unfortunately, this is not always good science. In my view, again, both the grizzly delisting and the wolf delisting are not really good ideas in terms of the science and the potential changes down the line. However, that has moved ahead, and we'll see how it goes. But hopefully, they will maintain their numbers. Now, as we look at causes of extinction, this would be really kind of a global look at causes of extinction, but many of these also apply in the Yellowstone ecosystem. Certainly one risk of going extinct would be feeding high in the trophic level. The higher you are in the food chain, the less energy you have available to you, the more opportunities there are for disruption in the food chain or food web. And typically also they're carnivores, which bring in other problems as well. That we'll talk about in a second. Being physically big typically puts you at risk of becoming extinct because you will require a lot of food, for one. You're easy to see in terms of being hunted, so that will put you at risk. Usually if you're big, you also have a low reproductive rate, you reproduce slowly, and if your population crashes, it'll take you a long time to recover. Having very limited or specialized breeding or nesting grounds can also put you at risk, because if something happens to those nesting grounds, then large numbers of individuals can die. In the case of the Yellowstone ecosystem, we don't have a lot of examples like this, but bats do actually form maternity colonies, and so you can have hundreds to thousands of bats in certain areas, and if something happens to those colonies, then you lose a lot of animals. Having fixed migratory patterns can put a species at risk, primarily from hunting, but again, they learn these migratory patterns, and if we don't protect the migratory pathways, as I talked about with the whooping crane, for example, then they don't have places to feed, they starve along the way, and they can never get to perhaps their protected areas in nesting grounds and wintering grounds. Also, having very specialized feeding habits can put an animal at risk. Again, an example I've talked about a couple times, the black-footed ferret, they feed on prairie dogs, so as the prairie dogs disappear, so do the black-footed ferrets. And then just having generally unhealthy behaviors, and this can be a variety of things. Kind of the classic example is the Carolina parakeet. If you killed a member of the Carolina parakeet flock, other members of the flock would hover around it to try to figure out and help it figure out what's wrong and help it in some way. And so hunters then could just wipe out an entire flock once they shot the first bird, because the flock would keep hovering around the injured birds. So anyway, it can be a variety of different kinds of things. The key deer in the Florida Everglades are addicted to nicotine. They forage along roadsides, and then cars hit them, and that's not good for that population. Being generally intolerant of humans can put a species at risk of becoming extinct. In the Yellowstone ecosystem, attacking humans, like grizzly bears, that's one type of intolerance. That's not a good thing. So when bears attack humans, those bears are going to be put down, so that's not good for them, obviously. And then there are other types of intolerance. Bighorn sheep, for example, are just, they don't like to be around people very much. They try to avoid people. It can affect their breeding and so on. So there are various aspects of intolerance that can put you at risk for becoming extinct. Having valuable parts. There is quite a bit of illegal hunting that goes on of bears, for example, to harvest their gallbladders. The gallbladder is used in Asian medicine as an aphrodisiac, as I recall. So anyway, poaching can put a species at risk for extinction if it has valuable parts. Also, valuable fur would be something like that as well. Preying on livestock is a good way to get killed if you're an animal. So again, grizzly bear, wolf, and this is an issue that I'll try to come back to in a few minutes. But livestock are run throughout the ecosystem. In the national forests, also, they have historically been run even in some areas of Teton National Park. Now, the last couple of years, the last few ranchers that were doing that have stopped running their livestock there, but still around the periphery of the national parks, you do have cattle being grazed, or cattle grazing in the national forests. And the problem there is that if you want to expand grizzly territory, if you want to expand wolf territory, they are going to be encountering livestock, and livestock are pretty easy prey for them. Surprisingly, though, the number of kills of livestock annually are incredibly low, surprisingly low. Having a limited distribution obviously would put an animal at risk of going extinct, because they just don't have very much habitat. If something happens to that habitat, they're going to go extinct. Building roads creates opportunity for people to come in, increases hunting, increases roadkill. So just road building in and of itself actually leads to death of a lot of animals. And then climate change, which I'll talk about in a second, is a severe risk for a lot of species. But globally, the biggest cause of extinction is loss of habitat. That's the biggest factor. If you reduce habitat, animals are going to die, and plants as well. If you expand habitat, you have a better chance of keeping the species. So that is the major cause of extinction globally, loss of habitat. All right, now a related topic, and in fact, as we talk about species and being at risk, and as in a management issue when we look at the Yellowstone ecosystem, is greenhouse warming. So I want to talk a little bit about global warming and its effect on the Yellowstone ecosystem. So as we look at greenhouse warming, global warming, the name comes from the fact, or from how a greenhouse works. And I'm hopefully you're familiar with greenhouse. Greenhouse is made generally of clear plastic or glass. And so what happens is that light, strikes the glass. Some of that is reflected. Some of it passes through into the interior. And as it passes through the glass, it changes the wavelength of light so that it will not irradiate out at the same rate that it irradiates in. And so energy accumulates inside the greenhouse, and so heat accumulates inside of the greenhouse. So even though it may be cold outside, as long as it's sunny, the greenhouse is warm. So it's a cheap way to have a warm area. And then, of course, you can get your plants in the greenhouse, and they'll survive cold winters. Well, as we look globally, what is occurring in greenhouse warming is that solar energy reaches the planet. Some of that solar energy is reflected in the upper atmosphere by water droplets and dust particles and so on. And that's known as the albedo. So about a third of the energy that reaches the planet actually is reflected in the upper atmosphere. The rest of the energy is absorbed by the planet in various ways, and eventually will be irradiated back into space. And that irradiated energy that has been absorbed is known as Earth's emissivity. So emissivity is a rate of release of energy back into space. So what's occurring in greenhouse warming or global warming is that we've had a change in emissivity. Emissivity is decreasing. And as a result, energy is coming into the Earth's atmosphere and being held longer and released more slowly. So without a change in albedo, without a change in the reflectivity, in the same amount of absorption, but a decreased amount of radiation, energy is accumulating, and that's warming the Earth. And as we look at global warming then, what's triggering this change, the reason emissivity has changed, is primarily due to carbon dioxide, also methane. And as we look at the major greenhouse gases, really the major greenhouse gas is water vapor, believe it or not. So water vapor is an important greenhouse gas, but that's somewhat mitigated by the fact that water vapor, when it condenses on dust particles, can cause reflectivity and increase albedo. But it is a greenhouse gas. But in terms of human production and human impact on Earth, carbon dioxide is really the primary greenhouse gas that's human produced. And so again, carbon dioxide in effect acts as a blanket holding energy in, and that's leading to global warming. Another important greenhouse gas, which you don't hear as much about, which is really significant, is methane. And methane's kind of the wild card in global warming, and I'll talk more about it in a couple of minutes, but it's also of tremendous concern. And then there are a number of other greenhouse gases, but they're of lesser importance. Nitrous oxide, which is used as a fumigant primarily for control of fungi. And then ozone, which has another role globally, can contribute to this. Chlorofluorocarbons can contribute to this. But really it's the big three that I'm going to have you worry about would be water vapor. And then in terms of the big two that humans influence carbon dioxide and methane. So as we look over global temperatures, I mean, there's really no question that the Earth has been warming since about the 1970s, certainly through the 80s, 90s, and into this century. And again, that trend is really indisputable. One of the arguments that some people put forward is that, well, what is the cause really? Is it a greenhouse warming? Is it due to a solar warming? Because there have been some periods in this 30-year period of increased solar activity, although that's not really a measurable change per se, but that can also influence changes in temperature, a solar warming. And so if you think about solar warming and the warming that we see, it's kind of a different type of warming. So there's some reasons why we consider it to be and think it and are confident that it is a greenhouse warming as opposed to a solar warming. One is that if you think about where the sun hits most frequently, it's going to be in the tropical latitudes. And those aren't the areas of the Earth really that are warming most rapidly. The areas of the Earth that are warming most rapidly are in the poles. So the polar regions are where we get the most warming, and that is consistent with the models put forth by increased carbon dioxide and methane. So that is better explained by a greenhouse warming as opposed to a solar warming. So that's one of many arguments. Also, carbon dioxide levels have continued to increase since the dawn of the Industrial Revolution. And as we increased greenhouse gases, that has gone along with warming of the planet. So when you look at the scientific community, there is consensus that greenhouse warming is contributing to this warming. And even if we make the argument, or if we look at, let's say we're graphing global temperatures, even if global temperatures fluctuate and do fluctuate due to solar radiation increases and decreases, and let's say that there is a period of solar radiation increase here, there is no question that there is a greenhouse influence on that. And so if we add to what would be the normal warming through radiation, if we add to that a bump from greenhouse warming, which we are certainly experiencing, then that can be a critical difference. That might be the difference between, to be honest with you, whether humanity survives or not, quite frankly. So, you hear a lot of politicians, and again, it's not scientists making these claims in the scientific community, but you'll hear politicians say really absurd things like, well, carbon dioxide is a harmless gas. Carbon dioxide is in my carbonated beverages. How could that possibly be harmful to the planet? And that's just almost silly, to be honest with you, because the reality is that carbon dioxide is a greenhouse gas, and those kind of things to me are just kind of crazy talk. But unfortunately, that's what some of our politicians are doing. So as we look at warming and its effect on the Yellowstone ecosystem in particular, what we're looking at here is changes in the carbon oxygen cycle. So again, we're producing carbon faster than it can be taken out of the atmosphere by the plants. But in terms of its consequences in the Yellowstone ecosystem and ecosystems in general, is that we're really looking at warmer winters. So this is one of the really important aspects of this, is that the highs annually are not increasing as much as the lows are increasing. And so in the case of the Yellowstone ecosystem then, these warmer winters have severe consequences, especially when it comes to something like pine beetles and their ability to survive, their larvae being able to survive the winter. They used to freeze to death because used to have temperatures of minus 30, 40, 50, even minus 60, minus 70 in the winter. Those kind of temperatures would kill larvae that were in the bark of trees, but those kind of temperatures just aren't happening anymore. So larvae are able to survive winter and continue to kill trees, in particular that white bark pine population that is being devastated. So as a result then, also we're seeing an earlier spring. So spring is coming earlier than it used to by weeks. And that may not sound like a lot, but that is significant in an area like the Yellowstone ecosystem where the growing season is relatively short. And so there's really a frantic pace to feeding in the summer to try to get ready for the next winter. So you might say, well, that could be a good thing. Well, in a sense it is, but what happens is that with the earlier spring, you also have an early snowmelt, and you have a fairly dramatic snowmelt, because the summers are also going to be warmer. So whereas in the past, snow would melt more slowly through the summer, by the end of the summer, you would still have quite a bit of water in streams and so on, and you would have ponds and all kinds of things, and we're not seeing those anymore. So I was just actually reading a study last night, actually looking at amphibian populations, and one of the reasons the amphibian populations are crashing in the Yellowstone ecosystem is just that the ecosystem is drying out. There's not as much snow in the winter. Also, the snow melts earlier. It melts more completely early in the summer. So by the end of the summer, where historically, if you went back 30 or 40 or 50 or 60 or 70 or 100 years ago, you had all of these ponds in the ecosystem. Those ponds are drying up now. And so anyway, frogs and salamanders can't reproduce in those ponds. And so that's partly what's contributing to the population crash there. So also, this earlier spring creates problems. So there's a loss of coordination in migration, breeding, and food supply, because typically what happens is that animals will breed and migrate at times when the food supply will be at its max along their migratory pathways, and also when food supplies will be at their max when they start breeding. So we do have situations where birds are migrating earlier. They're getting perhaps to the ecosystem at a time when food productivity is not as great. And I haven't seen this documented specifically in the Yellowstone ecosystem, but in other ecosystems, many songbirds, for example, are suffering because they'll migrate earlier, they'll breed earlier, and they're missing the peak season of food supply. And so then their babies starve to death. Other problems, as I mentioned, continued drought. So this has been a fairly consistent trend over the last 30 years, extended periods of drought. We expect that to continue. The drought then leads to more fires. More fires contribute to more carbon dioxide, which creates this positive feedback loop. In the Yellowstone ecosystem in particular, the whitebark pine deforestation is significant because it impacts other species like the grizzly. So that is definitely putting the grizzly at risk. Also, the warming is putting the pika at risk. And as I've mentioned previously, the pika is being listed by U.S. Fish and Wildlife right now. And amphibians. So this also then creates greater opportunity for invasive species that prefer drier habitats, and that's also happening in the ecosystem and changing the ecosystem. So again, this is a big problem. And so when we look then at the federal agencies responsible for trying to manage all of this, this is also part of the problem. It's kind of the management problem. So as we look at the ecosystem, at the heart of the ecosystem are the national parks. So two of the federal agencies that are involved in management of this ecosystem would be the National Park Service. And the National Park Service's role is to promote and regulate the use of national parks, which purpose is to conserve the scenery and natural and historic objects and the wildlife therein, and I think that's really important to hear, and to provide for the enjoyment of the same in such manner and by such means as will leave them unimpaired for the enjoyment of future generations. That's another really important phrase. So their role is to provide access, but it must be preserved for future generations, and they must protect the wildlife therein. So those are really important phrases in their the documents associated with the service in their role. Now, the Fish and Wildlife Service also is important in management of endangered and other types of protected species. U.S. Forest Service is involved in management of the national forests, and that's part of the buffering area around the national parks. And then the Bureau of Land Management, as we get around the very edges of the periphery of the ecosystem, the BLM lands or resource lands that are used for mining, oil deposits, gas deposits, that kind of thing. Other local agencies also are playing a bigger role. So Wyoming Game and Fish, the Idaho Fish and Game, Montana Fish and Wildlife and Parks, Bureau of Indian Affairs, because there's an Indian reservation, the Wind River Reservation, to the southeast portion of the ecosystem. And the Wind River Reservation and officials associated with the Wind River Reservation also play a role in management of species and of the ecosystem. So again, we've really got kind of a management mess here because you have so many different agencies and individuals involved. And as we've talked about in both wolf and grizzly management, a lot of that management is being put on local agencies. And as we look at national lands then, I think it's very important that they be managed from a national perspective as opposed to the local perspective. So there is a trend to try to emphasize local management and local concerns, and I think that is a huge, huge mistake. National lands should be national concerns. And then these lands that are managed then include the national parks, wilderness, and wilderness is very important because these are lands designated for preservation and protection in their natural condition, and it's going to be an area where the earth and its community of life are untrammeled by man. So wilderness designated areas and true wilderness then is an area that is pristine and it's maintained in that way. So much of the territory within the national park, especially Yellowstone National Park, is currently being proposed to be true wilderness. And so again, this is that dynamic between providing access but not destruction of the habitat. Now this contrasts with national forests, which are resource lands, and they practice what's known as silviculture, which is basically agriculture of the national parks, of the national forests. So to some degree, they are expected to be harvested, but we also have to think of them in terms of a different kind of resource, which is the wildlife resource. So they do have a resource in terms of wildlife, and in some areas, and perhaps in this area of the country, maybe that should be the major emphasis as opposed to harvesting of trees. Also, we have national wildlife refuges in the park as well, and again, they can be administered by different agencies. And then certainly national resource lands, which would be under the auspice of the BLM. And again, these would be lands designated for mining and oil reserves, among others. So these are lands, again, which have some tangible resource value. Maybe it's ore, maybe it's oil, something of that nature. So a very complex ecosystem in terms of management. So even when you do studies and you decide you have a general scientific goal, perhaps that scientific goal doesn't hold up very well over time because you have so many agencies with conflicting perspectives and conflicting priorities at work here. So, and this is really one of the biggest challenges to the ecosystem and whether it will persevere or not. So again, I really think that this trend towards local control, local management is a huge mistake because when you look at the Yellowstone ecosystem, over 3 million people come in a year. When you include the Tetons, probably getting closer to 4 million people. And I don't know the population of Wyoming, but that's probably bigger than the population of Wyoming. So those national concerns should be important. So it's really, I would just like to say it's really been a privilege to bring this class to you. And one of my goals at the beginning of this was to say that I hope that you, as you learned about the ecosystem, would value the ecosystem and want to go there. So I'd like to invite you to accompany us to the ecosystem one of these days. And if not, you need to get up there on your own and see it for yourself. Take care.